Hello everyone again. My name is Jens Miller. I'm a PhD student at the Chair for Network and Data Security at the University of Bochum. And today I'm giving you an introduction on our current research, a joint work on printer security. You may ask, why would anyone want to try to attack printers? Why should we matter about those devices from a security point of view? Well, printers are quite everywhere. They're contained in every household, every company, every educational institution, and they have access to sensitive information, like, for example, business contracts being printed, like patient results, or yet unpublished research. And today I'm going to show you how incredibly easy it is to access those documents using 35-year-old vulnerabilities present in almost any laser printer. Okay, here's an outline of today's talk. First, I need to give you some technical background information so you get a better understanding of the attacks to follow. Then I'm going to show you an evaluation with 20 printers using our Python toolkit, Bread. And then I'm going to show you how to adapt the attacks to areas beyond printers, like, for example, to websites. Okay, let's start with some technical backgrounds. What does it actually mean to print? If you want to print a document, you basically need to do two things. First, you need to choose a printer language, printer channel, excuse me. So a channel that is used to actually print the payload, like, for example, USB cable or one of various network printing protocols. And the second thing you need to do is to decide which printer language you use. So, for example, PostScript or PGL. So the language that actually contains the document being printed. And there are many proprietary languages, but PostScript and PGL are supported by almost any laser printer. That's why we focused our research on those languages. The important takeaway here is that the attacks are independent of the printing channel. So whenever the attacker is able to print, she can perform the attack. Okay, now let me give you a short introduction to PGL and PostScript. PGL, the printer job language, was developed by HP in the 90s, and it soon became a de facto standard language for print job control. Now what can you do with PGL? For example, you can set the paper size to A4 or set the number of copies. The important thing here is that those settings are not necessarily limited to the current print job, so you can potentially influence further print jobs. And there are other interesting features with PGL. So, for example, you can access the printer's file system through an ordinary print job. The other language of interest is PostScript. PostScript was the very first product of Adobe. And some of us may remember it as a format for document exchange. However, PostScript was originally designed for and is still heavily used on laser printers. So if you want to print a document, for example, a PDF file, and you use PostScript as a printer driver, what your printer driver does is actually it simply converts the file to PostScript and sends it to the printer. The important takeaway here is that PostScript is not a simple page description language. PostScript actually is a Turing-complete programming language. So from the viewpoint of theoretical computer sciences, given access to a PostScript interpreter already means code execution, because any possible program, any possible algorithm can be implemented in PostScript and executed on the printer. Okay, now let me come to the attacks. Our methodology in finding attacks was to systematically collect already available information, for example, vulnerability reports on printers, and to systematically study the standards, PostScript and PGL, and look which features, which legitimate features of those languages are critical from a security point of view. Before coming to the attacks, I need to define 3 attacker models so you can see who is actually able to perform the attacks. Our first attacker model is the attacker with physical access to the device. It's quite a strong attacker model. However, ask yourself, is your department's copy room really always locked? Is your conference's printer really never ever unattended? Well, it's only a matter of seconds for an attacker to launch a malicious print job via USB cable or USB stick and therefore permanently infect the printer with, for example, PostScript malware. Our next attacker model is the attacker with TCP IP network access to the printer. Again, you may ask, who would connect his printer directly to the internet? Well, lots of people do. These are current numbers from Shodan, the search engine for devices. And Shodan currently categorizes about 34,000 computer systems out there as printers. Actually, it's a lot more, but consider an attacker who just wants to randomly target some printers, and she can use Shodan and find over 10,000 devices alone in the US. Our weakest attacker model is the web attacker. All she does is control the contents of a website, and she somehow manages to lure an employee within the same local area network than a printer to be attacked to her website. Now, she's able to execute JavaScript in the employee's web browser, and therefore trigger HTTP post requests to port 9100 of a network printer, and therefore again send PostScript files, for example, or any other print jobs, execute PostScript code on the printer. So the web attacker is able to perform all the attacks to follow. In other words, a malicious website can read your print jobs. Okay, now let me give you some examples for the attacks. If you want to cause a simple denial of service attack, what always works is an infinite loop in PostScript. As said, PostScript is a programming language, and it's got all the constructs of a programming language, like loops. And by sending this single line of code to the printer, it tells the printer to do nothing forever and efficiently get stuck. So usually until the device is turned off and on again. Another example is bypassing protection mechanisms. Let's assume there is a system administrator, and he does his job very well, and he has set passwords everywhere. Even the printers are password protected. So our attacker wants to change some settings, but she can't. She doesn't know the password, right? What she can always do is, if she has got physical access to the device, she can simply press certain keys documented in the manual and therefore reset the device to factory defaults. Okay, what is more interesting is that, for example, on HP printers, you can reset the device to factory defaults through ordinary print jobs. So by sending this line of PGL code to the printer, the device will reset itself and restore factory defaults and therefore wipe out all protection mechanisms like passwords, for example. Only with the ability to print. Okay, here's another example for the manipulation of other users' print jobs. Remember, PostScript is a programming language, and one of the interesting features of PostScript is that you can override functions, operators of the language itself. And when a certain operator is now called in a subsequent print job, the attacker's version is executed. So this can be used, for example, to overlay arbitrary graphics, but also to replace text in a document of other users. For example, to introduce misspellings into the printouts of a certain user you don't like, or to lower the price in a sales agreement to be printed. And with the very same principle that you can hook into other users' print jobs and access the data, you can also capture print jobs since decades on every PostScript printer. In practice, there were some challenges actually we had to solve. For example, where do you store the captured print jobs? If the printer has got a hard disk, that's easy. We can use PostScript to access the hard disk and save the files there. Else, we need to define PostScript variables in memory and put the data in there. Later today, the attacker comes back and downloads the captured print jobs. Okay, now let me give you an evaluation of the attacks. One problem actually was how to find enough test printers. And what we did is we contacted our university's system administrators and asked if they couldn't give us some devices for science. And that worked quite well in the end. We got 20 printers from 8 different manufacturers, and it may represent a good mixture of what is used in a typical university or office environment. Okay, here are the evaluation results. We categorized the attacks into 4 classes. This is the denial of service class of attacks. On the left hand, you can see the printer manufacturer, and red always means the device is vulnerable. For example, the infinite loop with PostScript almost always works. But there are other possibilities to cause denial of service attacks, for example, using PostScript or PGL. And we were even able to cause physical damage to the printer on 8 devices because we could exceed the printer's possibility to accept new NVRAM values. Because the printer's NVRAM, like with all embedded devices, it only accepts a limited number of write cycles. But within a print shop, you can cause 1 write cycle, or you can cause within a large print shop 1,000,000 write cycles, and therefore destroy that unit. Okay, bypassing protection mechanisms work for about half of the devices, and for some devices even through ordinary print jobs. The manipulation of print jobs, like overlaying content, replaying text, also work for most of the devices. Accessing the printer's NVRAM only worked for Prada-based devices. Accessing the file system only worked for 2 devices to access the complete file system. But on many devices, we had read and write access through ordinary print jobs using PostScript or PGL to certain directories only. This is not harmless because often you can find passwords in there, like for example the device password, but also the scan to email credentials, or IPsec and Wi-Fi pre-shared keys, and so on. So this may be a good example how to escalate into a network using the printer as a starting point. Capturing print jobs and credential disclosure attacks against PostScript and PGL also work for various devices. Okay, now let me give you an introduction to Bread. Our print exploitation toolkit is a Python software that easily allows you to automate the attacks. It's released under the GPL and available on GitHub. Now, what can you do with Bread? If you want to analyze your printer, you can type ls or 30 other commands, typical Unix-like commands. It is parsed by Bread, translated either to PostScript or PGL, and sent to port 9100 of a network printer. So you do not need to speak PostScript directly. You just type ls, and Bread does all the rest, translates it to a PostScript request, fetches the PostScript response, and finally displays the results of a file listing on the printer in a user-friendly manner. And the same with PGL. Okay, now we thought, can we adapt the attacks to areas beyond printers? And this is pretty hard for PGL, because PGL is tightly bound to printers only. However, PostScript is used in various other areas too. For example, in the web. First, we thought, well, maybe let's have a look at PostScript to PDF conversion websites. So, because converting PostScript actually means interpreting, means executing PostScript on the web server. So there are not that many of those websites, but those that we found, most of them were vulnerable, at least to information disclosure attacks. Okay, but the problem is more broad. We recently analyzed the top 100 online image converters, and we found half of them being vulnerable to the same attacks because they accepted EPS files. What is EPS now? EPS stands for Encapsulated PostScript, and it's commonly known as an vector image file format, but actually it just contains plain PostScript again. Okay, now you may say, my website is safe, I don't convert any images, right? Maybe you allow your users to upload profile images and generate thumbnail previews. And then again, the framework that is used for image manipulation in the background, for example, ImageMagick, may again allow EPS code to be executed. So let me give you an example. Here is Dropbox. On Dropbox, you can upload EPS files, and they generate some preview image. If you generate a preview image, you must interpret the PostScript code, the EPS code, and what we have here in the thumbnail preview is a directory listing on the Dropbox server, and we can see it in the thumbnail preview. So this is not really a problem for Dropbox. We met with them, and they have some sandboxing around, and it's not the real file system that we see here, but not all websites have such extra layers of security. Okay, now let me come to a conclusion. In the paper, we systematically analyzed PostScript and PGL, the printer languages, and we found both of them, from the standards on from the implementations, to be insecure. And actually, countermeasures are pretty much hard to apply because we only attacked the languages that are used for printing itself. So, for example, to capture print jobs, we only use legitimate features of the PostScript language. And we applied the attacks to different areas beyond printers, like to websites, for example. And further research may include having a deeper look at firmware updates, because it is common in the printing industry to deploy firmware updates as documents that are printed. Also, we may have a look at controlling the fax channel of MFPs through print jobs, through PCL commands, so the attacker gets access to the phone line, or adapting the attacks through 3D printers. Okay, let me come to the end of the talk. Brett, our Python tool to analyze to pen test printers, is freely available. Test your printers, give me some feedback. And if you're more interested in the technical details, we've set up a wiki where all the attacks are explained in depth. Okay, do you have any questions?
Let's thank the speaker. Oh, I see people moving fast. Okay. Or you're moving out, or going for a question? No, moving out. Oh, there you go. Then I have a question. So you're talking about printers. It was known in the community that these devices were sort of like broken or have problems with security. So what is, in your opinion, the angle that is different in this case from just pen testing yet another device? What is the specific that makes this different?
Well, in my opinion, the interesting thing with printers is that you actually have data and code over the same channel, because when you can print, you can do administrative functionality on the printer. There's no separation of rights. Whoever can print can basically execute code. So that's quite interesting.
Isn't that a case, for example, also for databases? But you know, we don't study. I mean, we studied attack to databases, but is there something that goes beyond the pen test of a certain technology? Do you find something that is really printer specific that capture your attention, apart from the execution of code, which of course is bad?
Well, okay, execution of code is maybe very abstract. Printer control in general, I would say, and doing this over the printing channel itself, I think that's really the most important thing. And think about it, 20 years ago or 30 years ago, when they invented PostScript, this wasn't a problem at all. It was years before the web. But nowadays, printers we don't speak to printers using the parallel port anymore. Printers are network printers. We can use a website to attack the printers. So I think the manufacturers exactly knew that it may be kind of dangerous, but it wasn't a problem in a closed environment. But now it's a problem to still support those languages. So it's pretty easy to attack printers.
Okay, is there a question down there? Okay, oh, there is one.
Hi, John Criswell, University of Rochester. So one of the things I thought was interesting was the fact that you mentioned physical access. And I imagine it's a pretty hard problem to deal with printers, because you have to pick up the paper from the printer, right? Do you have any ideas on how that could realistically be solved?
It's kind of hard. Physical access control. Well, if you only allow trusted users, for example, to access the printing room, the copy room, that would work. Also, what you can do is on the network level, you only allow certain users, and it is possible to use strong authentication for printers based on IPP, based on HTTPS, to only allow really certain users to print, and then you type a certain PIN, and then the paper is released. So no one else is able to access the printer, and you must trust your users, of course. That is possible, but in real-world scenarios, I've never seen that implemented.
Okay, let's thank the speaker again.